Good evening friends. In this segment, I am going to explain you projectile motion. Projectile motions comes in the motion in the plane. Basically, in the last segment, I have explained you there are three kinds of motion exist: motion in 1D, motion in 2D, and motion in 3D. Our projectile motion comes in motion in 2D or motion in plane. So first of all, I want to just give you the basic idea of projectile motion. Let's suppose if any body is thrown vertically in the atmosphere and air resistance and all other parameter can ignored. If all other parameter can be ignored and if any body is thrown vertically and it is moving under the effect of gravity only. So that particular kind of motion is called projectile motion. Okay, if any body is thrown vertically in the atmosphere and only gravity exists there due to the gravitational effect of earth, if body is moving, so whatever the path, whatever the velocity, whatever the energy contained, that we have to study. So that particular motion is called projectile motion. Okay, there are basically three kinds of projectile motion exist. One is oblique projectile motion, horizontal projectile motion, and projectile motion in the inclined plane. There are basically three kinds of projectile motion exist: oblique, horizontal, as well as inclined plane. The projectile motion in the inclined plane. So I want to just give you the basic diagrams of these three projectile motions. Okay. So let's suppose if any body is thrown vertically upward with the initial velocity u, which is making an angle theta degree with respect to horizontal. So its path will be like this. Means in a oblique projectile motion, the body comes again on the same horizontal line from where it has been thrown. So that particular projectile motion is called oblique projectile motion. Horizontal projectile motion, let's suppose this is our ground and with respect to this particular ground, from at a particular height, if body is thrown horizontally, and other parameter like air resistance and other force are not present, then it will just move like this, its path will be like this. So this kind of projectile motion is called horizontal projectile motion. In an oblique projectile motion, body is thrown from the ground and it will move under the effect of the gravity in the atmosphere, and after that it will come down to the earth surface. And for the horizontal projectile motion, the body is thrown from any particular height in the horizontal direction only. So it will move like this. This is our horizontal projectile motion. And one more form is there, projectile motion in the inclined plane. So just see here, let's suppose I am just considering any inclined plane. Let's suppose this is x axis, this is y axis, and I am just considering any plane, inclined plane, making an angle theta degree. Okay. So if I am just throwing any particular object from this inclined plane and it will come again this it will come again on this inclined plane. So that particular kind of projectile motion is called projectile motion in the inclined plane. So these are some basic things. Now I am just going to give you basic definitions of the projectile motion which will be helpful for you. So some basic parameter of the projectile motions are flight time, range, maximum height. Firstly, we will see these three parameters and we are just trying to know that what is it. Flight time. I am just considering firstly the oblique projectile motion. So let's suppose this is the case of our projectile motion which is known as oblique projectile motion. Okay. Let's suppose any body is thrown vertically, making an angle from horizontal is theta and the velocity is u. Okay. So I just thrown this particular body, this is y, this is x. So the time till which it will remain in the atmosphere, so that particular time is called flight time. Okay. The total time taken by the body in its projectile motion or the total time taken by the body to be remain in the atmosphere is called flight time. Means from this particular point A to come again to this particular point B, whatever the time is taken by this particular body, which velocity is u, that particular time is called flight time. It is generally represented by capital T. Range. Range is a total horizontal displacement, total horizontal distance covered by this body in its projectile motion. So the total horizontal distance covered by this particular body in its projectile motion is called its range. So let's suppose from this particular point to this particular point, whatever the time, so I am just supposing that time is t, so that time is called flight time. That time is called flight time. And for range, for this from starting point to end point, whatever the horizontal distance, so horizontal distance is called range. So it is what? R. Now the maximum height. With respect to ground, whatever the maximum height attained by the body in its projectile motion, that is called maximum height. So let's suppose in this particular projectile motion, with respect to this horizontal axis, or you can say ground, whatever the height, maximum height covered by that particular body, that is called maximum height. So range is represented by R, maximum height is represented by H. Okay. These three parameters are there. We can find further parameters. Let's suppose if we need to find kinetic energy, so we can use the formula half mv square, where we need to find the velocity component, total velocity component. For the projectile motion, there are some consideration which is important to know. So just see that what are the consideration which has been taken for the projectile motion. Let's suppose any body having the initial velocity, that is u, which is making an angle from the horizontal, is theta. So now velocity is a vector quantity and we can just resolve its horizontal and vertical component in the desired direction. So this u will make u cos theta from this horizontal axis and u sin theta in the vertical direction. That is why this particular body, let's suppose I am just considering a motion A to B. So we have to just see it practically. In this particular motion, the object is moving like this. Okay, so what is actually going on in this phenomena, we have to understand it. There is a velocity component u cos theta by which it is just moving ahead or it is moving in a right direction. That is why it is just moving from this particular point A to B due to this particular component u cos theta. Means by the help of u cos theta, it is just moving in a forward direction, and due to this u sin theta component, u sin theta component is applied in a vertical direction. That is why it is moving in a vertical direction. Okay. Now there is a role of gravity which we have to understand. Gravity will affect the u sin theta or the vertical component. This is very important point, that the gravity will affect the vertical component of velocity only. Affect the vertical component of the velocity only. This is due to the fact that at a particular height the g value changes. Okay, so g will affect only this u sin theta component. U cos theta will unchanged. Throughout the motion. This is important concept for the solution of the numericals. You should know that the vertical component of velocity will change at the different point, but the horizontal component of the velocity during whole projectile motion will not change. Means this will remain same, but this will vary at the different point. Let's suppose if I am just considering at this point, this particular location, let's suppose this is point B. Sorry, this point I am just considering C. So just see here, from this point it is just moving in this direction. So I am just considering, let's suppose this particular point, if its velocity is V, okay, and with respect to this particular angle theta, this will also a theta. Okay, so if this is V, so it will be V cos theta and that will be V sin theta. So our important consideration is this V cos theta must equals to this U cos theta, because earlier I just told you that the horizontal component of the velocity will never change. The change is what? Only in the vertical direction of this velocity due to the gravity. Okay, so V sin theta will change, means at this particular point, let's suppose the V component in the vertical direction is V sin theta, so this will change with respect to this U sin theta, but this V cos theta will equals to this U cos theta. Horizontal component will not change anywhere. Okay, so let's suppose there are certain formula which you need to know. Let's suppose at any particular point we need to find the total velocity, we need to find the velocity. Okay, so as we know, if two components are there, okay, we have to study this two component in a different directions. So both are the mutually independent with respect to each other. Means if I am just considering a horizontal motion, because this is a case of motion in the plane. So motion in the plane can be break into two portion, motion in the 1D. So if I am just considering a horizontal motion only, then I have to take only U cos theta component. We will not consider this vertical component. But if I am just considering the vertical motion of this particular body during its projectile motion, then I have to take this U sin theta component. And at any point, and let's suppose at any point if we need to find the total velocity, then always we have to use this formula, that V is equals to under root of Vx square plus Vy square. You need to understand that what is Vx and Vy. Vx is the horizontal component of the velocity and Vy is the vertical component of the velocity. If I have vertical component as well as horizontal component, then I can use this formula and at any point we can get the value of total V. Now you have to just look here. Okay, let's suppose from this particular point A to this particular point C, the time taken by the body is small t. Okay, time taken by the body to reach from this particular point A to C is small t. If I need to find the value of the vertical component of the velocity, so I am going to use the first equation of the motion, that is V is equals to u plus at. But this is a case of retardation, because with respect to ground, if I am just moving in an upward direction, so that is opposite to the gravitational field direction, because the gravity will always just try to make any body towards itself, towards its center. But if I am just moving in a vertical direction, then that is a case of retardation. So that is why I have to use the motion equation V is equals to u minus gt. It is just derived from the equation that V is equals to u plus at. But if the retardation is there, then V is equals to u minus at we will use. But here the acceleration is what? Acceleration, only the gravitational phenomena we have to consider. That is why I am just taking small g, acceleration due to gravity. Now see here, let's suppose the vertical component is V. I am just considering the vertical component V dash. What? V dash, or you can just write Vy. What? Vy. So Vy is equals to the vertical component, this is u. Means if I am just considering a vertical motion only, then I have to take a vertical component only. So at starting, the vertical component of the velocity is what? U sin theta. Means in a place of u I can put what? U sin theta minus gt. So by the help of this particular formula, I can just find the vertical component of the velocity at this particular point C. Now if I am just considering for the horizontal component, so as I have just told you that horizontal component of the velocity will never change, means it will always remain this u cos theta at any point. At any point this will remain same. So Vx will be equals to this u cos theta for all the point. Now let's suppose if I need to find the total velocity at this particular point C, so directly we will use this formula that V is equals to under root Vx square plus Vy square. So now just put the value of Vx and Vy, then we will get u cos theta square, and in a place of Vy I can put this value. So that is what? U sin theta minus gt of whole square. This is the standard formula for finding the total velocity at any point for the projectile motion. Directly straightforward we can use this formula and we can get the result for the velocity. Okay. Now you see there are some basic formula. For finding the range, maximum height and the flight time. Okay, so let's suppose I am just considering the half projectile motion till its maximum height. Okay, I am just considering the half projectile motion. So let's suppose this is h max. I have taken this is h max, or which you can consider is equals to y, and from this particular point I have taken this x distance. What? I have taken the x distance. Let's suppose this is the starting point and the velocity, initial velocity is u, and this is what, theta. So this is the vertical component and this is the horizontal component. The horizontal component will be u cos theta and the vertical component will be u sin theta. Okay, there is a one question arises, at the maximum height, what will be the velocity? This is very important, and we need to know that during the projectile motion, what is the maximum height point and what is the total velocity at the maximum height point. So let's suppose if any body is just moving in a vertical direction. So at the maximum point, one component v sin theta, due to this v sin theta, the body is just moving in a vertical direction. So let's suppose if somewhat velocity is there at the maximum height, means let's suppose if any vertical component is there, so then it will rise more, somewhat more it can rise. But if there is a v sin theta, if there is a vertical component like u sin theta is 0 for this particular point, then it will just gain its maximum height. So for reaching a maximum height, the vertical component of the velocity will be always 0. So which component will be left? Only the horizontal component. So this is important, at the maximum height, vertical component of velocity is equals to 0, and then the total velocity of the body is equals to only due to the horizontal component, and that component is u cos theta. So at the maximum height, the total velocity will be equals to what? U cos theta. What? U cos theta. Okay, so let's suppose if I am just considering a vertical motion for A to C. If I am considering the vertical motion from A to C, so from the first law of equation, we can just put that v is equals to, Vy is equals to ui minus gt. Let's suppose if the time from A to C is t. Okay. Now the initial velocity component is u sin theta, but the final velocity component at C, vertical component is 0, means at this particular maximum height, the Vy will be 0. So if Vy is 0, and in a place of Uy I can put u sin theta. So u sin theta minus gt, and from here you can get the value of t, that will be u sin theta upon g. Means for reaching a body from ground to maximum height, the time taken by the body is u sin theta upon g. So what will the flight time? Flight time is just, if the body is taking a time from this point to this point is t, then again it will take from maximum height to come ground is t. Means the flight time, important thing, the flight time will be, the flight time, let's suppose t is equals to what? 2t. Flight time is 2t. Now we can just get the value 2u sin theta upon g. This is the general expression of the flight time. If you are knowing the velocity and angle, then you can use this formula, that t is equals to 2u sin theta upon g. This is the formula for the flight time. Now let's suppose if we need to find the range. If I need to find the value of range, then I can use range, means distance, and distance is equals to velocity into time. So the total time from this particular point A to B will be equals to flight time, and the velocity in the horizontal direction is u cos theta. So I can just find the formula for the range. Range is equals to, it is just distance, and distance is equals to velocity into time. So we have to take a u cos theta component because it is horizontal distance. So for finding the horizontal distance, we have to take a horizontal component of the velocity. So that is why I can use that r is equals to what? It is just u cos theta into flight time, and that is capital T. Now I can just put the value of capital T, then r is equals to u cos theta, and flight time value, that is 2u sin theta, as we know, 2u sin theta upon g. Now we can just solve it. We can write u square, then u square into 2 sin theta into cos theta upon g, and we know it that 2 sin theta into cos theta is equals to sin 2 theta. So r is equals to u square sin 2 theta upon g. This is the formula for the range. One more parameter, h max, we can just find. Just by using the third equation of the motion. Let's suppose if we need to find the h max, so we can use this formula that v square is equals to u square plus 2as. Okay, if I am just putting a gravitational term and I am just considering a vertical motion from A to C. If I am just considering a vertical motion from A to C, then what is the vertical displacement? The vertical displacement is equals to h max, and the vertical velocity at point C is what? 0. So means, let's suppose Vy for vertical component, the vertical velocity at point C is 0. So means Vy will be 0, and Uy, in a place of Uy I can put u sin theta. So here I am putting u sin theta square plus 2, and if I am moving in a vertical direction, so I have to take minus g component, and in a place of s is a displacement along the motion. So from this particular point A to C, what is the vertical displacement? That will be equals to h max. So here in a place of s I can put h max. Okay, now just solve it. So means you will get the value 2g h max is equals to u square sin square theta. From here you can get the value of h max, that will be equals to u square sin square theta upon 2g. These are the basic fundamental things which we need to know for the projectile motion. In the next segment I will explain you that how to find the particular standard equation of the projectile motion and why its path is parabolic. That I also have to explain. Thank you, class.